Welcome to the Explainer. Today, we're going to trace the literal digital backbone of our modern world. We're looking at the evolution from chaotic, raw data to the highly efficient database management systems we all rely on today. It's essentially the story of how we learned to tame the absolute chaos of information.
Here's our roadmap for today. First, the basic resource, then data versus information, followed by the file system era, problems with file systems, and finally, the database solution. Okay, let's dive right into section 1, the basic resource.
To really get databases, we've got to start right at the foundation. I mean, think about it. Every single organization on the planet relies on one absolute basic building block to operate effectively, and that's accurate, reliable data. Just think about the everyday systems we interact with constantly. Whether you're pulling cash from an ATM, booking a railway ticket, checking into a hospital, or just doing some online shopping. None of these systems function without a continuous flow of accurate data.
So, before we get into the complex management stuff, let's take a step back and ask ourselves, what actually is data at its absolute core? We throw the word around all the time, but the technical distinction really matters. Technically speaking, data is just raw facts and figures that have some kind of implicit meaning. But because it's completely unorganized, just totally raw, it cannot support decisions on its own. It's purely input. It's just sitting there waiting for a job to do. Now, what's really interesting about this is, well, take the number 25. Without context, it's literally just a raw figure. Is it a temperature, a quantity of items, a price tag, somebody's age? We have absolutely no idea because it hasn't been organized or given any context whatsoever. It definitely can't help us make a decision. Here are a few more raw examples straight from our source material. Rahul, Kolkata, 500. Again, these are completely unorganized names and numbers. They leave us totally guessing about their actual meaning. Is Rahul traveling to Kolkata with 500 rupees? Is Kolkata 500 kilometers away? As pure data, they are just isolated little fragments. Moving right along to section 2, data versus information. So, the crucial point here is what happens when we take those isolated, unorganized, raw facts and finally give them some actual context and structure. Information is what we get when data is finally processed and organized. While data is just the raw facts, information is the meaningful, structured output that we can actually use for decision-making. Simply put, information is data with a job to do. Looking back at those raw fragments we saw a moment ago, when we combine the raw data points of the name Rahul with the number 25 and we process it, boom, we suddenly get meaningful information. Rahul is 25 years old. The ambiguity is completely gone. The raw inputs have become a clear, understandable fact that a system can actually use. When you look at this direct comparison, the core shift is moving from unorganized input to decision-driving output. We're taking raw, meaningless facts and giving them structure. You move from the input side, where things just sit idle, over to the output side, where processed, organized data actively helps organizations make critical decisions. Let's move to section 3 and see how this builds, the file system era. Okay, so once early computer scientists figured out how to turn data into information, they hit a massive logistical wall. How do we actually store and manage all this stuff? The early prototype for organization was the file system. By definition, a file is a collection of related records stored in secondary memory. You can think of these exactly like those old, clunky metal digital filing cabinets. A university would have a student file, or a business might maintain an employee file. You get the idea. But here's the catch. The mechanics of this early file-oriented approach were inherently flawed. In this era, there was a separate file for every single application. An app pointed directly to its own isolated file. And because of that strict one-to-one relationship, the data was highly program-dependent. System maintenance was an absolute nightmare. And it inevitably led to massive amounts of data duplication across different departments within the exact same organization. Which brings us to section 4. Problems with file systems. This early approach really crippled growing organizations. First, we had data redundancy, meaning the exact same information was saved over and over in different files. And naturally, that led to data inconsistency. I mean, if a customer updated their address in the billing file but not the shipping file, which one was correct? Then there was data isolation, where files couldn't easily talk to each other, creating massive silos. And finally, integrity problems. It was practically impossible to ensure the data was actually accurate and valid across the entire company.
And the structural nightmares didn't stop there. There was a lack of atomicity, which is just a fancy way of saying if a system crashed halfway through a bank transfer, you could lose partial data and money could just vanish. They also suffered from concurrent access issues, where two people trying to update a file at the exact same time would create total system chaos. And of course, there were glaring security problems, making it super difficult to lock down specific sensitive parts of a file.
Finally, we reach Section 5, the database solution. Thankfully, technology evolved to save the day and fix these specific flaws. A database is an organized collection of related data that is shared among multiple users. Contrast that with the isolated file system we just looked at. Instead of redundant, separate files for every single application, a database is a centralized, highly organized pool of data that multiple applications and multiple users can safely access and share at the exact same time.
And this brilliantly illustrates the 4 key checkmarks of a modern database that fix all those problems of the past. It is organized, so no more raw, chaotic facts. It is integrated, completely eliminating those massive data silos and redundancy. It is shared, meaning multiple concurrent users can access it safely without breaking the system. And it is persistent, meaning your data is stored securely and permanently, ensuring integrity even if the power suddenly goes out.
As we wrap up this explainer, I want to leave you with a provocative thought. What would actually happen if your ATM used a disconnected, unorganized file system today? Imagine the sheer chaos of redundant bank accounts, concurrent access failures when you and your partner check your balance at the exact same time, and absolute security nightmares. It really makes you appreciate the precise, invisible mechanics of how databases operate under the hood to keep our complex, modern infrastructure from totally collapsing. Thanks so much for joining me on this explainer, and keep questioning the data around you.